Hey, Pocahontas.
Hey, Da Vinci.
I was thinking about IR spectroscopy the other day.
Weren't we all?
There's no need for sarcasm.
I'm sorry. It's been a tough week.
IR spectroscopy is awesome.
Is that the one that uses infrared radiation?
Yes.
I thought so.
Infrared radiation can make bonds vibrate.
Ionic bonds?
Not really.
Ah, covalent bonds then.
Yes. But not all of them.
Why is that?
To interact with a bond and obey the laws of physics, a bond must be able to change pole moment if it is to absorb IR.
What does that mean to me?
For you it means that the bond must be polar.
Polar? Like having an appreciable difference in electronegativity?
That's right. Different bonds bend and stretch at different frequencies.
Is that because of the different atomic masses and the different bond strengths?
Yes, it is. If we irradiate molecules with the full range of infrared frequencies, some will be absorbed as it makes the bonds stretch and vibrate, and some will be transmitted straight through.
So it is a form of absorption spectroscopy?
Yes. In fact, greenhouse gases absorb infrared radiation that would otherwise be reflected into space. This makes the atmosphere warmer than it would be without them there.
So the Earth is warmer than it would be without them? I guess that's good for having life on the planet.
Yes, but there are worries about there being too much, particularly CO2. Water is a very powerful greenhouse gas as well.
What do I need to know for the DP?
The TP.
No. Don't say stuff like that. The IBDP?
You need to know how a double beam spectrometer works and how to apply the ideas to organic chemistry.
Tell me about the double beam spectrometer.
It's bare cool. An infrared beam is produced and passed through a monochromator.
What's a monochromator?
It makes sure that only one wavelength or color passes through.
I see.
The radiation is split. Half goes through the sample, and half goes through the reference, which has all the same apparatus as the sample, but with no test substance in it.
What's the difference then?
The beams are detected and compared. The sample beam has some missing frequencies, because the sample's bonds will absorb some energy that the reference won't. The spectrum we get shows the difference and what frequencies are being absorbed by the sample.
So we can see what bonds there are?
Yes, exactly.
How do I use this in organic chemistry?
Simple organic chemicals contain CH bonds, CO bonds and OH bonds.
Like alcohols, carboxylic acids and carbonyls?
Yes. These absorb different frequencies and we can say which of these bonds are present.
Can we say what functional groups are present?
Not necessarily. We might have to use other techniques to make absolutely sure.
Are there any other ways of describing this?
I am glad you asked. There are, yes.
Like what?
Imagine you go dancing and different drinks make you dance in different ways.
Like champagne makes me dance differently to Red Bull?
Just like that. Different frequencies make the molecules dance in different ways. I don't even drink Red Bull, so I will dance differently to you.
Dancing is awesome.
I am awesome.
You mean, I are awesome.
Ha ha ha.